Welcome to qnawire.
To calculate the pH of the solution of 0.7 molar of HClO, the information that we require is pK for this weak acid. So the pK in this case is equal to 7.53. That means that our dissociation constant is equal to 10 to the minus 7.53. Thus, this acid, when it reacts with water, ClO plus water, is going to produce H2O plus ClO minus. Let's write down our ice table in terms of molarity. Initially, we're going to have 0.7 molar, 0 of the products. Water doesn't matter because it doesn't enter into the equilibrium equations because it is a condensed phase. The amount of change, we're going to call it minus x, plus x, and plus x. This is the fraction of the acid that is going to dissociate in water. So at the equilibrium, we're going to get 0.7 minus x, and x. The value for Ka of the acid is equal to 10 to the minus 7.53, which is a very small value. And this is going to be equal to the concentration of H2O plus times the concentration of ClO minus divided by the concentration of HClO. So, replacing the concentrations with the ones that we found from our ice table, which are the following, what we're going to get is x times x divided by 0.7 minus x. So over here we could go ahead and solve the quadratic expression resulting from this. But since we know that Ka is going to be small, we know that, or at least we expect to x to be much smaller than 0.7. That means that 0.7 minus x is going to be approximately equal to 0.7 directly. Employing this approximation, Ka, which is 10 to the minus 7.53, is going to be equal to x squared divided by 0.7. We can solve for x, giving us x is equal to the square root of 0.7 times 10 to the minus 7.53. And this value of x is going to be equal to the concentration of H2O plus that we're going to have in equilibrium, as we saw from our ice table. Remember, this is concentration at equilibrium. So, solving this, the value for x is equal to 1.437 times 10 to the minus 4 molar. Indeed, this is much smaller than 0.7. And as we mentioned, this is the concentration of H2O plus. So the pH is equal to minus the logarithm of the concentration of H2O plus that we're going to have in solution of the hydrogen ion, and the result is equal to 3.84. So this would be the pH for our solution. Let me put it in red to emphasize that this is our result. And that would be all. Thank you very much and have a good one.